Hi, teaching team. This is our process video. My name is Colin. That's Michael.
I
So talking about what technology was used to create it, an Arduino microcontroller was used in tandem with a electromagnet, HC05 Bluetooth module, temperature and humidity sensor, and a Hall effect sensor. We initially planned to create the electromagnet from scratch, but decided on getting an already working electromagnet from eBay. Once we had the electromagnet, we ordered a Arduino compatible Bluetooth module and used the Arduino Uno R3 kit to supply a breadboard and temperature and humidity sensor. We first tried an ultrasonic sensor, but brought a Hall effect sensor later in the project as we discovered that it wouldn't work.
With help from online source, we use the code that took advantage of the ability of the home monitor sensor to send back the distance of the magnet and use the two buttons that would increment and decrement the distance at which the electromagnet would turn on or off. The idea was to use the buttons to find its extend distance at which the magnet will flow, and when the magnets start to drop, the electromagnet would turn on the vice versa.
So our processes undertaken, most of our time was spent trying to get our magnets to float with the electromagnet and the sensor. We tried several different setups of the electromagnet and different strengths of the permanent magnets, but had trouble committing to a final design when we could not get the magnet to float in the first place. We attempted to troubleshoot our code. So we tried to use an ultrasonic sensor, like I mentioned, to take the place of the Hall effect monitor, but realized after we put it into practice that the delay on the sensor would be much too high for something as delicately balanced as a floating magnet.
We try numerous amount of the magnets and designs for the plan, but each one usually ended up either too heavy or too light. In addition to the material covering magnet would mean that the distance to the electromagnet was increased, causing a weaker saturation force. We got the temperature and humidity sensor working near the end of our project, as we had devoted most of the time to getting the materials and trying to get the magnets to flow. We managed to create an acceptable design even though it did not look perfect. We still did our best to hide the wires and create a seamless look.
So what things didn't work, we still needed to make our planet float more stably. We are almost the way there, but never quite got there. We also needed a better control box to hide the wires separately and think about how to put the buttons outside to make it easier to control. We ran out of time to create a new app to display the temperature and humidity via Bluetooth, which ended up with us using an app from the Android Play Store to interface with the Bluetooth module. So the ultrasonic sensor, like I mentioned, turned out not to work. The cloche dome also turned out to be too big for the project, as the electromagnet only affected a small distance from itself. And the attachment of the wires to the base meant that the cloche could not be easily opened and the magnet could not be easily placed. Additionally, we ended up wasting time with testing our magnet when we discovered that we had gotten a Hall effect sensor, a switch instead of a sensor, which would not work for our purposes. So we have some leftover images where the temperature and humidity was not displaying for us because the sensor broke. And our final wiring setup. The successful temperature and humidity displayed. And the final artifact. Thanks. I think that's everything.